Hello everybody and welcome to SpaceWeek Live for Sunday, March 7th, 2021. So, as always, this is a live Q&A session. If you have any questions, please ask them in the chat and make sure to tag my name. Just say rawspace or @rawspace and we'll be sure to see the questions, which I will answer at the end of the episode. So, last week was an eventful one. As far as launches, it's been pretty quiet, but there's some important stuff going on. So let's take a look. Let's see. Last Sunday evening, the Starlink 17 launch, which had been delayed multiple times since early February, got all the way down to 1 minute 24 seconds when an automatic abort was triggered. Let's check that out.
You can start to see some, or hear some hissing, and see those white clouds starting to form around Falcon 9. That is normal for us at this stage. The white clouds are LOX venting from our transport erector lines.
Launch abort has started.
It does look like we have held the countdown.
So, they did not, there was no indication at the time of what caused that abort, but they did fix the issue, and then 4 days later, on Thursday, they managed to launch Starlink 17 successfully.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
So, unlike other Falcon 9 launches, there was no first stage booster camera this time. SpaceX mentioned this, but they didn't explain the reason why. I'm also unaware of any official explanation for why this mission was delayed so many times. Normally, normally scrubs and delays happen as a result of weather, but there was something else going on with this particular launch. Compared to many launch providers, SpaceX is pretty open and transparent, but not absolutely so. So yes, this was the great view we had after the launch of excuse me, of a dark screen. So this was the 8th successful launch of this specific booster and the 75th booster landing overall. And the current Starlink satellite count is 1,141. If you recall, the previous Falcon 9 launch back on February 15th failed to land on the drone ship, sparing the lives of 3 seagulls. Last Monday, SpaceX revealed that this failure was due to hot gas penetrating a small hole in a cover surrounding one of the first stage's 9 Merlin engines, causing the engine to shut down during ascent. The mission was able to proceed successfully, but the failed engine didn't allow the booster enough thrust to successfully land on the drone ship, and so it splashed down. Excuse me. I just ate a slice of pizza, and it's making me hiccup. Sorry. I figured it would be better to do the episode with a full stomach, or at least a not empty stomach, so pardon for that. Let's see. Oh, yes. Then on Wednesday, SpaceX made history with their first non-explosive landing of a Starship test vehicle. Starship SN10 lifted off beautifully, ascended to a height of 10 kilometers, did a belly flop back down toward the Earth, flipped into a vertical position, and touched down on the landing pad. Now, I did say non-explosive landing, so before I get to what happened after the landing, let's bask in the glory of this almost perfect flight.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. We have liftoff. All teams, triage alerts, please. FC2, please prepare for section 35. OSC, FC1, LVN.
T plus 30 seconds, Starship 10 has liftoff. It's headed to 10 kilometers on its test flight from Boca Chica in Cameron County, Texas. Coming up on T plus 2 minutes, we're getting ready to transition from 3 engines to 2 engines firing on Starship. We'll be shutting 1 engine off. That's intentional. T plus 3 minutes and counting. Starship coming up on 8 kilometers altitude. We're getting ready to shut down the second engine. This is intentional. I'm clear. Oh, very nice, very nice. Okay, now to switch over to the header tank for the one engine. Okay, I'm going to come back up when we hit 10 kilometers, right about in 3 seconds. Coming up on T plus 4 minutes, we're at 10 kilometers. We've gone into the hover. We're still being powered by the single Raptor engine.
So, if you're not familiar, the way the Starship flight profile. Oh no, my voice seems to have driven away Bennu. If you're not familiar, the Starship flight profile involves using 3 engines to boost upwards, and then gradually cutting out one engine and then another until they're left with a single engine to very slowly and carefully approach the target altitude of 10 kilometers, at which point they pitch it over into a belly flop maneuver where the fin surfaces take over for aerodynamic control on the descent to keep the spacecraft stable. Well, it's not yet a spacecraft, but to keep the vehicle stable during its descent. Then as it approaches the ground, it uses both its RCS thrusters and the engine gimbaling of the Raptor engines to kick the vehicle into a vertical orientation again, which it is about to do here. So, just for a sense of perspective, Starship is 160 feet or 50 meters tall. It's the height of approximately a 15-story building, and so that is what we're seeing being controlled on its descent. Now, that's where the let's see. That's where the SpaceX broadcast ended, with the apparently successful landing of Starship SN10. Now, alas, shortly after the SpaceX broadcast ended, SN10 abruptly blew up. So here's some video courtesy of Lab Padre. Yeah, and there was some synchronization offset between the thermal cam or predator cam and the main Nerdle camera. So that's why you see it appeared. Yeah, that's why you saw the aftermath of the explosion on the thermal cam at a different time than the other one. But yeah, so here is a slow motion view courtesy of NASASpaceflight.com. So a few different folks had cameras trained on the rocket, and so here's another one. You can see the shockwave there jostled the camera. So yeah, unfortunate, but I don't know. Elon Musk didn't seem to mind. He tweeted that it was actually fun, but he's a bit of a well, he's a unique individual. Let's put it that way. So SpaceX hasn't revealed any details of their investigation of the incident, but an analysis of the available footage shows that some of the landing legs weren't locked in their downward positions as SN10 landed. They were sort of flopping around. And the landing itself looked pretty hard. It looked like it came down at too high a velocity. And the rocket, after the landing, the rocket was tilted slightly on the pad. You could see it in the even in the SpaceX footage. You could see that the rocket was not fully upright, indicating that not all the landing legs were supporting it. So the combination of a hard landing with inadequate support from the legs probably caused structural damage to the fuel tanks, which led to a compromise and the rapid unscheduled disassembly, which we just saw. As always, SpaceX will take the lessons learned and make the next iteration of Starship even better. Then on Thursday, the Perseverance... Oh, I have my stuff out of order here. There we go. On Thursday, the Perseverance Mars rover took its first baby steps on the Red Planet. Its first drive covered a total of 21.3 feet, or 6.5 meters, in 33 minutes, about 0.007 miles per hour. The short mobility test was one of many tests and preparations that have to happen before the rover can dig into its science mission. The rover's controllers at JPL also wiggled a wheel, flexed Percy's robotic arm, and checked out many of the rover's other systems, instruments, and experiments. In the short time Perseverance has been on Mars, even before its science mission really begins, it has already sent more than 7,000 images, which you can view for yourself in raw form on NASA's Mars 2020 website, which is, what is it, mars.nasa.gov/Mars2020, I think it is. And then, let's see, then on Friday, there was another spacewalk. I want to apologize again for not streaming the previous spacewalk last Sunday. I tried to upload a video of it after the fact, but due to a YouTube glitch, I couldn't upload anything. This has happened to me twice now, and it's pretty annoying. I don't know if it's something to do with my browser, my computer, or just YouTube being glitchy. But anyway, Friday's spacewalk marked Japanese astronaut Soichi Noguchi's historic return to the vacuum of space after 15.5 years since STS-114 back in 2005, which itself was the historic first return-to-flight shuttle mission after the loss of Columbia in 2003. On his final EVA of that mission, Noguchi photographed and inspected Space Shuttle Discovery's heat shield and removed a couple of protruding gap fillers between the shuttle's heat tiles. Friday's EVA was both Noguchi's and fellow spacewalker Kate Rubin's 4th spacewalk. It was also the second in a series of spacewalks to prepare the ISS for solar array upgrades, which you can see the solar arrays here. Originally designed for an operational life of 15 years, the first of the station's 4 pairs of solar arrays were installed the first of the space station's 4 pairs of solar arrays were installed more than 20 years ago in December 2000. The most recent pair of arrays were installed 12 years ago. They are all still working well, but they're showing signs of age. In order to ensure the ISS is able to support the upcoming Artemis missions, the continuing commercialization of space, and the ongoing plethora of scientific research they do up there, 3 of the 4 solar arrays are getting some help. The new ISS Rollout Solar Arrays, or IROSA, are smaller and more efficient, and will be mounted in front of the old solar arrays, which you can see here. They will reuse the existing sun tracking, power distribution, and channelization systems that are already on the space station. The new arrays will shade about half the length of the old arrays, but overall will increase the ISS's power production by up to 30%. A total of 6 IROSas will be delivered to the station in pairs in the unpressurized trunk of SpaceX's Dragon 2 cargo ships starting later this year. Each of the installations will involve 2 spacewalks, one to install a modification kit at the mounting point, and one to attach the new array. In other news, Rocket Lab, maker of the diminutive Electron rocket that launches from New Zealand, made a big announcement this past week. They are working on a big rocket called Neutron. It will stand 131 feet or 40 meters tall, have a 4.5 meter fairing, and be able to carry 8,000 kilograms or 8.8 tons to low Earth orbit. Similar to SpaceX's Falcon 9, Neutron will use LOX and kerosene for fuel, and the reusable first stage will land on an ocean platform. No idea what they'll name them, but it's sure to be creative because Rocket Lab likes to keep it fun. Rocket Lab is expecting a first launch in 2024. Now, once upon a time, Rocket Lab's founder Peter Beck once said that he would eat his hat if Rocket Lab ever moved toward making their boosters reusable. Well, he stayed true to his word.
So I really think with this project, it's about time I finally ate the hat. This hat is not tasty. But there's some things we said we would never do.
So, yeah, there you go. Good job, Peter Beck. So, yeah, there he is standing inside the payload fairing, or half the payload fairing, of a Neutron rocket. So, well choreographed there by Rocket Lab. So, I played that clip at the expense of getting a copyright ding for that music, but if it shows up, I'll just remove the music after the fact. The heck with them. Alright, so because this isn't monetized anyway. I haven't been monetizing my SpaceWeek episodes the last few times because I found that when I go back and view my own episodes, the advertisements irritate me. And so I would prefer, and if they irritate me, they surely irritate you. And I'd prefer that you come here for the content, not to get bombarded with advertisements. So I haven't been monetizing the episodes. But if you would like to support the channel, there are numerous ways to do so, which are now enumerated in the chat, including memberships, super chats, PayPal, Patreon, etc. So, let's see, do I have anything more for last week? Nope, that was it for last week. Looking ahead to this next week, on Tuesday, March 9th at 9:58 p.m. Eastern, 02:58 GMT on the 10th, a SpaceX Falcon 9 rocket will launch Starlink 20. Then on Friday, March 12th at 8:34 a.m. Eastern, 13:34 GMT, a Chinese Long March 7A rocket will launch the mysterious and classified XJY-6 satellite. This will be the second payload, called XJY-6, since the first one was destroyed by a launch failure in March of last year, also on a Long March 7A. I believe that was its inaugural flight, wasn't it? As usual, no live coverage of Chinese launches. Then on Saturday, March 13th at 5:06 a.m. Eastern, 10:06 GMT, SpaceX will launch Starlink 21. 2 Starlinks in 1 week, if there are no scrubs. I don't recall if there have been 2 Starlinks launched in a single week before. I know they've been scheduled for such. I don't recall if they actually happened due to scrubs and delays. Then next Sunday, and this is non-space related, but sort of on an administrative note, next Sunday, March 14th at 2 a.m. Eastern, daylight saving time will begin in the U.S. and many other places. Spring ahead, fall behind. That means my launch schedules will be listed, starting next Sunday, my launch schedules will be listed in Eastern Daylight Time, or GMT-4. Up until now, they've been listed in Eastern Standard Time, or GMT-5. And of course, I will continue to list all times in GMT UTC as well. Now let's get to your questions. All right, so again, if you have questions, make sure to tag my name, Rawspace, so we are sure to see them. And thank you again, Chris V, for collecting these questions for me. Rockin' Robbins 13, what do you think of modifying Mars by terraforming or other processes to make it more hospitable for humankind? Well, I think that there are some monumental challenges to the process of terraforming Mars. I mean, the main problem of trying to be a human on Mars is that you can't breathe the air and you're being bombarded with radiation because there's no planetary magnetosphere which serve to deflect the majority of the solar ionizing radiation away from directly impacting the planet. And the Martian atmosphere is not only very thin, only a few percent of the density of Earth's atmosphere, but it's also comprised almost entirely of carbon dioxide, which that's not what we breathe. We need oxygen. And one of the reasons it is thought why the Martian atmosphere is so rarefied, is so thin, is because it got stripped away over the eons by the solar wind, because without the magnetosphere to shield the atmosphere from those high energy particles from the sun, Mars gets blasted constantly with solar radiation, and many atmospheric molecules are deflected away from the planet at a much greater rate than, for example, on Earth, where we have retained our atmosphere within the protective sheath of that magnetosphere. So planets are big, and even though Mars is much smaller than Earth, it's still big. The surface area of Mars is roughly equivalent to the land area of Earth. Now you think of all the land on the Earth, that's a lot of land. And similarly, the atmosphere of Mars is, an astronomically large volume that humans would have a very challenging time trying to make even the slightest dent in. If you consider all of the human activity on Earth, with the many billions of us crawling all over this planet and spitting out greenhouse gases and pollution and everything else over the past 100+ years since the Industrial Revolution, we've only had a moderate impact on our own atmosphere. It's measurable, but it's not like taking Mars' atmosphere and turning it into something that we can process in our lungs. So a project like that would take centuries at the minimum, perhaps millennia, perhaps it's impossible. So because even if you bombarded Mars with like comets or something to add water and to add, the oxygen to the atmosphere by way of, H2O, you would still have the issue of the solar radiation. And unless we come up with some whiz-bang device that's able to generate a magnetic shield to deflect solar radiation away from Mars, maybe situated at the Mars-Sun L1 Lagrange point or something like that, which is, sci-fi technology. There simply won't be a way to protect the Martian surface from bombardment by all that radiation. So, I love to romanticize about the terraforming of other planets as much as anyone, but realistically speaking, it's so far down the road that it's, we have other things that we can focus our efforts on at this point, because, it's we're talking like far human future. Okay. MVM Motovlog Music asks, is having the world's largest magnet as the landing pad and an electromagnet with the reverse polarity on a spacefaring vessel a complete impossibility? That's interesting. Magnet as a landing pad. Well, I presume... Well, if you're on a body with gravity, such as, Earth, Mars, the Moon, you're not going to need a magnet to land because you have gravity, right? The gravity of the planetary body is pulling down on the craft, and it's going to, accelerate the craft until it lands. Now on the Moon, there's no atmosphere, so there's no terminal velocity. On Earth, we have atmosphere, so we do have a terminal velocity, but anything that tries to land at terminal velocity is going to explode, or at least get crunched. Now, it could be possible to... The thing is, the way magnetic fields are, I don't know the formulas off the top of my head, but the way magnetic fields are, you would almost need like a corridor of magnets through which the craft descended, which would gradually slow down the craft's descent into the gravitational well, so that it could then come to rest perfectly on the pad. Because if you just had magnets around the launch pad, the craft isn't going to slow down until it's way too late, and it's going to just crash. So I think that magnets could, and also the velocity with which you need to escape a gravitational well, especially a big one like Earth, is significant. I mean, you need a lot of thrust, a lot of effort to get off of a planet. And, not so much getting off of a smaller body like the Moon, but you still need thrust. And, like I said, unless you have a corridor of magnets, basically like a rail gun shooting you into space, then, that's not going to happen. Now, I mean, a launch, is if you ever watch any of Isaac Arthur's videos, you're familiar, then you'd be familiar with all sorts of different launch mechanisms, including basically railgun launch systems. And that is a possibility, especially in places where you have either little or no atmosphere. But So I would say that a magnetic-based launch system might be feasible on the moon, but not really on Earth. All right. So hopefully that answers your question. Mr. Nebula 6000, what do you think that SN20 will look like? Of course, it was SN10 that just launched. SN20 will probably look a great deal like SN10. I mean, by that time they should be conducting orbital launches, and it'll have more Raptor engines, maybe the full complement of 6, which is, I believe, the final number of Raptor engines that the Starship upper stage, which they're currently developing, and that's what SN10 is, the upper stage of Starship, the Starship launch system. The first stage being Super Heavy, which doesn't yet exist. Although I think they have some parts for it ready. But anyway, I imagine it'll look very similar, because they don't need to focus on aesthetics, or they don't need a final design until, well, I think that, let's see. If it's returning from orbit, it's going to have to endure a lot more intense atmospheric forces than the current prototypes. So we may see it have a more smooth appearance, a little slicker, more, aerodynamic, but not greatly different. MVM Motovlog Music says, anyone else notice that SN10 reached its apogee at 420? I've at the time, honestly, when it did that, I was in my car, and like that day, that last Wednesday, I was actually in the midst of inspecting. I'm sorry, I have Bennu Cam up. I need to look at my stream more. Bennu disappeared a long time ago. I was actually in the midst of inspecting the new house I'm going to be moving into in a few weeks here. And by the way, when I do move, I plan to have a overlap between the new house and the old house, so I'll be able to maintain my 24/7 Starship Starman stream, and so yeah. Additionally, the new house happens to be in a Google Fiber service area, so I'm going to be moving from AT&T Fiber, gigabit-ish at my current location, to Google Fiber at the new location, also gigabit. Hopefully better gigabit. Let's see. Comment on Starship, Mark Desert. Amazing to see these large things hovering. It is really amazing. From Rockin' Robbins 13, also in regards to Starship. Interesting comment about switching to the header tank for the one engine. I am not a rocket engineer. I could not, off the top of my head, tell you what a header tank is. But there you go. Mark Desert. I've read it might be months before the Ingenuity takes off for its first hop. So in this 24-hour news cycle, headline-driven, TikTok, browsing society that we live in nowadays, people want fast results. They want things to entertain them at a rapid pace. Well, that's not really how space works. Space is space, rocketry, and space endeavors tend to be long periods of waiting patiently, followed by brief periods of sheer terror, such as the descent to the Martian surface by Perseverance. So the plan, NASA and JPL, extremely methodical, as they should be, because, oh my gosh, hello. Oh, Benno's yelling at me. Why? What's wrong, buddy? You gonna jump up on me? Okay. Oh, Come on. Come on. Okay, you want to get in your bed instead? All right, there he is. Here, let me adjust the camera real quick. 1 second. He's going to make some biscuits. So, Bennu. So, what the heck was I talking about? Oh, Ingenuity. So the Ingenuity drone, or robotic helicopter, as they call it, but it's a drone, or Marscopter. I think the plan to, because it's going to conduct a series of just a small handful, like maybe 4 to 6 test flights, very moderate distance and height. It's really a proof of concept mission. It's not going to be doing any real science. Hopefully they have a camera on the thing. I don't recall if they do, but they better. Which will then, that video will be transmitted to Perseverance, which will then transmit it to Earth, either directly or by way of the orbiting satellite. But yeah, so that's not going to happen for a few weeks, I don't think. First they have to get to the location where they're going to test it, and there's going to be a lot of systems that need to be checked out and tested prior to that. So one thing at a time. But yeah, once they do it, it'll be over. Like, one moment, please. I'm going to mute my mic. Here, I'll leave you with Bennu for a moment. 1 second. If I can find it. Sorry about that. Had to yell at my daughter upstairs to shush. All right. So, Maria C. Kutujan. Did someone challenge him to eat the hat? Yeah, so the Peter Beck eating his hat thing. He once said that he would eat his hat if they ever made a reusable booster. And so he made good on it, you know, this past week by literally taking a bite of his hat. A small bite. I mean, he didn't eat the whole thing. But it was a joke that, you know, that he followed through on. Mark Desire thinks I need to update the calendar again. I think the calendar's correct, unless there's been a change in the past 1 hour. Ian Pedlar says, so he ate his hat. Does that mean that hats will become a new source of rocket fuel? Probably not. I don't think that they are. I don't think they have a very high specific impulse. The nylon and cotton, whatever, polyester, whatever the heck they make hats out of. Tig Rayhoff. Any news about the science experiments that came back from ISS? There may have been some news on that, but I am not aware of it. So I'm sorry for that. Winter Zero. Do you think something like a water bear could live on Mars? Water bear being a tardigrade. Tiny little, barely visible but mostly microscopic. I guess they're big microscopic creatures that resemble like 6-legged bears, sort of, and have proved to be exceptionally hardy and can live in all sorts of adverse environments. Sure, I think that, well, let's put it this way. I think that it's possible a water bear might be able to survive on Mars if it had access to water. The thing is, Mars can reach room temperature, but usually Mars is quite cold. And so the water and the carbon dioxide on Mars is generally frozen. You know, in the polar ice cap, there's water, there's ice. I mean, there's a dry ice, but it's not like in liquid form. So you know, we do have pictures of water stains on the surface of Mars that look like, you know, seepage from underground or whatever. And so there is a minimal amount of water on the surface, not like in pools, but just sort of moist regolith, but it evaporates or, you know, freezes pretty quickly. And without water, a tardigrade will basically dehydrate and go into hibernation mode. Now it can survive, but it won't be actively, you know, moving around and trying to find food. Additionally, Mars doesn't have any food. So unless there's a source of, you know, microbes or plants or whatever it is that tardigrades eat, it's not going to be able to consume anything on the surface of Mars. It could certainly survive inside the human habitat, because it's going to have atmosphere, it's going to have water, it's going to have, you know, humans are chock full of bacteria and microbial life, and you know, so is the rest of Earth, for that matter. And you know, that I think that's pretty much the extent of it. Is tardigrades on Mars would have to be inside of a human habitat of some sort, or a sheltered habitat in which there could be liquid water and some source of food for them. And finally, RUD, or backwards R Epsilon D. Can't the Starship have bouncy landing pads, so even if it lands in a high velocity, it can still bounce and land safely? That's an interesting idea, sort of a landing trampoline. The problem with elastic surfaces, such as a trampoline, is that things bounce in unpredictable ways. And when you have a craft that's coming down, if you can precisely control its landing, such that when it lands on a trampoline or an elastic surface of some sort, that it bounces in a controlled fashion, then you can also control its descent so that it lands on a hard surface precisely and not at too high a velocity. So, you know, because the control of the descending spacecraft is entirely contained within the spacecraft, you know, you don't have ground systems that are like controlling the descent of the spacecraft, like those magnets we talked about earlier or whatever. Although I wonder if, like you remember how I said that the magnets don't have a long range, like that if you had magnets at the launch pad, they could only really slow down the craft at the launch pad. I wonder if it might be possible to have a hybrid system, just mainly for redundancy and safety reasons, that if the craft were coming in at slightly too high a velocity, the magnets would be able to engage and basically control the landing such that the craft didn't land too hard. It's an idea. But, alright, so that's all the questions that have been asked that I am aware of. Yep, that is it for now. So thank you all for coming, and oh, okay, good. Ben is there. Yep, thank you all for coming. See you again later this week for the upcoming streams, and again next Sunday in person for Space Week. And until then, keep it raw.
Thank you.